Hi everyone, and welcome to this, the final episode of my SAB Lizard build. In videos 1, 2 and 3 we installed all the main components, so the servos, the landing gear and of course the turbine. I didn't show you where all the smaller parts went at the end of that last video, as I had to check where they all needed to go to get the right CG and for everything to fit. So I'm going to show you real quick where everything went, and then we're going to dive into what this video is actually about, and that is setting up a plane like this on your radio. I'm going to show you exactly how I set up something like this. Now, this may seem quite daunting when you start because there's a lot going on, but hopefully by the end of this video, once you see how I do it all, it should hopefully seem a bit easier, and you may even be able to copy a few of my crazy methods. After all, this thing does have vector thrust on elevator and rudder. It's a delta wing, it's got a canard, it's got dual rudders, it's got a gyro. Anyway, enough talking. Let's have a look at where all those parts went, and we'll get straight into programming the radio. Starting at the back, we have the turbine and the vector system. All of that was installed in one of our previous videos, and all that's new here really is the ECU wire, which runs forwards along with the rudder servo wires and the vector servo wires. All of the servo wires in the plane run down that side of the model, with all of the landing gear and fuel lines running down the opposite side, so keeping everything nice, neat and simple. Over here we have our fuel tank, which is actually velcroed to the top of this plate. This plate is then simply screwed in place, which keeps everything tight. The fuel tank obviously then feeds forwards into the UAT, which feeds the pump, which then powers the turbine. Coming into shot here we have the Powerbox Systems GPS, which will adjust in flight the gyro sensitivity or gain automatically dependent on the speed, so something else we don't need to worry about. We can here see the wires coming down for the Powerbox Pioneer, which is controlling everything with unregulated power. On top of this plate, well, we don't have anything, so as I didn't need to install anything on it, I'm not going to install the plate. Make the plane just that little bit lighter. Underneath, of course, we have our canard servo, and that there is our gyro, the Powerbox Systems iGyro SAT, which plugs straight into the Powerbox Pioneer. Over here we have the controller for the landing gear, so the retracts and the brakes, the ECU for the JetCat P130RX. We have the switch for the Pioneer, which I had to lift up slightly, otherwise when the wheel retracts it would hit on the bottom of it. So if you do use that same pre-cut slot, which is the same identical size as the switch, be warned that you will have to lift it up by 4 or 5 millimeters. We then have the UAT installed as per the instruction book, and then at the very front, of course, we have our OptiPower batteries. I'm running two 2150 milliamp 2S batteries for powering everything in the plane. So going via the Pioneer, that's controlling all the servos, the turbine. I'm even taking out of there the power for the retracts, and then underneath we have one more battery, which is a 5000 milliamp 2S OptiPower pack, which is dedicated for the turbine. And with that setup, I've been very lucky, and I've actually been able to have the CG what seems to be exactly right without adding any extra weight. So we may need to adjust it after flying it, but that's exactly how it's going to have its maiden flight. Step 1. Cheat sheet. This is a cheat sheet which shows where each one of the servos is located on our receiver, or in this case my Powerbox Pioneer. That means that it's very easy to locate and then configure and program each one of those outputs without having to second guess if this is an aileron, if it's a rudder, if it's the throttle, or if it's the gear. Step 2. We can now set on our radio each of its channels to match all of those servos. So we need to go into our mapping channel. which is in functions in the Powerbox core, and here we have each one of all of those functions, and we've already assigned each one of those outputs or channels on the Powerbox. Depending on your radio, you may need to do it one way or another, but that's the easy part of the whole setup, especially when following step 1, which is our cheat sheet. Step 3. After binding our receivers, the next step is to make sure that those surfaces that we've set up as per the right channels also move in the right directions. So a quick check of each one of those surfaces should show whether things are working in the right direction or not, and if they aren't, simply reverse them as per your radio. In my case, I can simply go into the servo output and reverse as required. You'll be able to do the same with whichever radio you use. Step 4 is still a normal one that everyone is more than accustomed to, and that is setting the sub-trim, so the center of the surfaces, and the end points. Now what I'm going to say here is the center is really obvious. We're simply going to adjust the sub-trim as required to get the surface in its central or neutral position. Regarding the end points, my recommendation is to always set the maximum rate that you could potentially need or want. So based on the manual, check how much deflection you need on each surface, and then add a little bit extra to that and limit it with the end point. And in doing so, make sure that things like the elevators both go up and down the same amount to that absolute maximum, even if you probably won't ever use it. But do it this way and we'll see why in one of the next steps. Talking about really cool, why not check out my really cool new lineup of Pickering RC merch with t-shirts, caps and hoodies in an array of colours and different logos available. I'm sure that you'll find at least one that you like. With worldwide shipping, pick up yours today. Tag me on Instagram, Facebook or any kind of social media. I'd love to see which one you chose. Anyway, back to the build. Step 5. Continue with the less obvious, so the non-surfaces. Now of course it's really easy to see when the elevator, the canard or the rudders need trimming. However, how about the landing gear, the turbine and anything else that doesn't have an actual surface that you can view? Now in most cases, simply leaving them at the radio set 100% will work. However, depending on your radio, you may need to increase it to maybe 105 or 110% to get things like the landing gear going up and down correctly. Continuing on that train of thought, on this particular plane there are 3 kinds of movements that may not be initially obvious. The first one is simple and common to all jets and a lot of scale planes as well, and that is the steering. Now obviously you want the wheel to turn whilst it is with the landing gear down. However, with the landing gear up, you want it to be fixed. Now depending on the controller, if it's something like Electron Retrax, you don't need to worry about this because you can route that steering servo through the controller and the controller itself will lock it in place for everything except for when the landing gear is down. On this case, this controller doesn't have that feature and the servo is connected directly to the Pioneer. So we're going to have to do it with our radio. So let's have a look. If we just find our steering channel, which is that one there, we've already set it up to work with our rudder stick. And now all we need to do is we need to go into our curve. As you can see, I've already added expo because I have checked this plane over before making the video. However, if we just turn the plane off real quick, after all, we don't want the landing gear going when we don't want it to. So as you can see, we've actually set a dual rate, so control rate, dual rate is connected to my landing gear switch. So up and down. And all that does is I now have two positions or 2 rates for that steering. I have a rate for it with the landing gear down, so operational, minus 100 plus 100, as you can see on the screen, with its expo, and then the second rate, which is simply absolutely flat. So the flat line at 0, meaning that it's not so much that the servo is off, it just means that it has 0 movement, so it's going to be stuck in the middle. So as soon as you hit the landing gear switch, it goes to 0, and as soon as you bring the landing gear down, we're back to having full control over the steering. The second of the non-surfaces that we need to control is the gyro channel. So on this plane, as we'll see in a moment, I use very simple controls for vector and for gyro. The reason being, I'm rather stupid and I don't want to make mistakes with switches. So I'm going to have as few as possible. The way that the iGyro SAT works is that as standard, the center position is gyro off, and then switch one way is gyro gain A, and the other way is gyro gain B. Now in my case, I like to have it so that you have off, 1 and 2. So I need to modify the curve of that channel. So if we find our flight mode channel, which is that one there, we can see that we've set it up on this switch, and rather than having the off position in the middle, I want it there. So we have off, gyro 1 and gyro 2. So all that I did was, if we go into flight mode, look at the curve, we've modified the curve from the standard -100, 0, +100 to this kind of V shape. That means that the +100 remains the same, so this is still gyro position 2. However, in the center we'd normally have 0, which is now over here, which if you watch the blue line, it will move all the way across. Sorry, timer. These things only happen live. Okay, so as you can see, we now have a far position is at 0, which would normally be in the middle position. And in the middle position, we now have it at -100, which would normally be over here. So that's basically changed the positions of center and one way for the other way around. So we now have gyro off, gyro 1 and gyro 2. The third and slightly less obvious one here is the flaps. Why? This plane doesn't have any flaps. Well, not officially. However, as recommended by the manual, we're going to be using both rudders moving inwards as if they were flaps. So rather than going down, they're going inwards. On this radio, all we need to do for that is create a new function which applies to the same servos as the rudder function does. If, however, you're using something like a Futaba, then you'd need to do it via a mix. Anyway, so if we create the flap function, it applies to the same servos as the rudders, which are 4 and 5, which we can find at the top here, rudder 4 and 5, same servos. It's on this switch here, which is always my flap switch. And then we had to do a similar thing to the flight mode switch, because at the moment we've assigned it a 3-position switch, of which the center is 0, -100 and +100. Now of course we want the flaps always to go flap 1, flap 2, so always in the same direction. So again we've had to adjust that curve slightly so that the top position is 0 as opposed to being in the middle as it normally would be. The end point is always the same because that's the maximum flap, and then the middle position is basically taken away. So we've gone from 0 to 50 to +100, and the result, here we have the flaps going inwards 1 and inwards 2. As you can see, both of those moving inwards, however still working as rudders even when the flaps are on. The reason why I mentioned earlier about setting the maximum endpoints is basically for things like this. It means that even when you have another function moving a servo all the way to one side, and then you have a second function which is saying turn left, which is wanting to move it even further, in that case you want to have the travel limited, otherwise it would try and move the servo way beyond where you want it to go. Doing that, you know that the maximum is that, and no matter what functions go on top of it, it's not going to go beyond there and it's not going to cause any kind of problems. In this case, of course, we did also have to reverse one of the two servos for the flaps on the rudder, but that's just a case of going into each one of the two, checking which one it was, and reversing it so that rather than both going the same way, which would effectively be a rudder, one goes in and so does the other. And the bonus one, number 4, is of course the brakes. Now, depending on how you like your brakes, this may or may not apply. However, I like to not have to use switches. As I said earlier, I'm not good at remembering them. So instead, I use the elevator down. That means I don't have to let go of the radio to brake. I can just hit a bit of down and the plane starts braking. So again, if we find the brake channel, I'm controlling it with the same elevator channel, as you can see. And then all that I'm doing is on the curve. Again, we've had to modify the curve a little bit so that in the whole of the up elevator travel, there's no signal basically being sent to the brakes. So it stays at -100 for the whole part of the up elevator. Even for the first part of down elevator, because I don't want to activate it accidentally. And then quite an aggressive curve going up all the way up to +100, which would be full brake. This again, on this occasion, doesn't need to be on a dual rate, because as soon as the controller retracts the landing gear, it will automatically stop the brakes from working. Step 6, dual rates. Okay, this is where some people make this really complicated. Personally, complicated isn't good. My J10 is also a 3D jet, and I don't use any switches at all except for one switch which I use for the landing gear and one switch which increases the gyro gain for a hover. That's it. Fast flying, slow flying, medium flying, aerobatic flying and 3D flying is all done on the same rates, and that's exactly how I intend to set up this plane as well. The reason being, you can't make mistakes if there are no mistakes to make. On this first flight, I will be taking off with a few different dual rate positions on the elevators, ailerons and so on. However, that is only going to be for the first couple of flights for safety, in case it's too slow or too fast. I'm then going to adjust those expos and dual rates to leave just the one of them which I'm happy with all the time. The manual talks about fast flying and slow flying. I intend to get both of those together just by changing the amount of expo. You can fly with large amounts of deflection if you have enough expo. So at the moment I just have a dual rate here for the elevators, ailerons and the rudders. I always like it full anyway, so that isn't going to change. So elevator, dual rate 1 and dual rate 2. And the same will apply to ailerons. We have 3 rates, meaning that no matter how this thing takes off, whether it's slow, too agile or anything in between, there's going to be a rate to be able to control it easily and get it down again easily. But those will then be removed depending on which one I like the most. Based on that, the same is going to happen with the vector thrust. Again, some people complicate things, in my opinion, too much, with multiple different rates, different expos and so on. I'm going to have my vector on the same channel as my gyro, and the only reason for that is because I want to be able to have an absolute kill switch. Otherwise I wouldn't even have that. So my single gyro flight mode switch is going to have one position where the gyro is off and the vector is also off. So that's down. That's in case something starts going wrong, something goes unusual, you're able to kill it immediately. However, normal circumstances, I'm always going to fly in that middle position. That's going to have the vector on permanently. It's going to have the gyro on permanently on some basic rates used for flying. And then the third rate is the one that I'm going to use, which is going to increase the gyro gain on the vector for hovering. That's the only thing that's going to change between flight mode 1 and flight mode 2. The rates are going to be the same, the expo is going to be the same. That is only to hit once you're in a hover activate it for that extra stability, and then once you're finishing the hover, take it back into flight mode 1. So keeping it as simple as possible. So as we can see, in off position we have no vector, and then in the middle position we have it working, and then everything works exactly the same in flight mode 2. No differences, no changes, no possible mistakes, or at least as few as is humanly possible. Step number 7. Okay, we're getting close to the end. We've got our plane set up. All that's missing now is our gyro. Now in this case we're using the Powerbox iGyro Sat, which plugs into our Pioneer straight on its own, as does the Powerbox GPS, which will adjust the amount of gain automatically for us based on the speed of the model. Again, another reason that we don't need more switches is because the gyro and the GPS are going to do most of that work for us. So why complicate it for ourselves if technology is going to do it for us? Setting up the iGyro itself, I did a video on this recently. I'll link it above so as not to go into the whole detail again and make a super long video about it. But basically we're going to go into it via the radio in this case because it's the iGyro Sat. We're going to do the lift up, turn right process that's required for it to learn in which position it's been installed, and then we simply assign which outputs are actually relevant to the gyro, for which surface of gyro, and then the amounts of gain. Now the amounts of gain we don't know yet because we haven't flown it yet. I'm going to be leaving attitude assist or heading hold on for the flying surfaces except for the rudders, and I'm going to have the rudders and the vector thrust on normal gain, so without heading assist. The amount I'm going to start off with are going to be 20% and 30% all the way round, and then I'm going to be increasing those flight on flight. However, don't take those figures literally. They do vary depending on the servos, and as I said, they haven't been tested yet. It could be they're too much, or it could be they're not enough. So when we have our maiden flight video, and probably a couple of flights in after that, I'll come back to you all and let you know what kind of gyro settings I'm using for my flying, so that if you set up the plane with the exact same setup, servos are the same speed, servo arms are the same length, then you can at least use mine as a base. And if you don't, well, it doesn't really help anyway, but you can have some kind of an idea and then base yours as required. And finally, we have step number 8, and that is the most important of all. You're about to go maiden your brand new SAB Lizard or whatever plane it is that you've just set up. Before doing anything else, double check everything. Make sure that the gyro is working in the right direction. Make sure that the servos are working in the right direction. Make sure that you've added expo to all of those channels. Make sure that the dual rates are active, that you're comfortable with them, you know which way they are, and if you feel better for it, have someone come out with you, stand with you during the maiden flight who knows exactly where all those switches are in case you get a bit nervous or you need some help finding a switch because for whatever reason, whatever plane it is becomes a bit of a handful. Other than that, I would say this plane is now good to go. I'm looking forward to having the first flight with it, and I look forward to sharing it all with you guys. What do you think? Do you do any of these mixes the way I do? Do you have a better way, or do you think I missed anything? If you do, let me know in the comments. I'd love to hear your opinions. We're going to get this thing in the air. Now, I did say this was the last episode of my SAB Lizard build, and it is. That doesn't mean though that we're not going to be showing you the maiden flight and successive after that as well. But they're no longer builds, they're the fun part, flying. So until then, thanks for watching. I really hope that you've enjoyed this video series. A little bit different to my usual, showing you all the steps of the build. If you enjoyed it, if you want to see more content like this building, leave it in the comments below. I'd love to hear from you all. And until then, thanks for watching, and I'll see you all in the next one. I'm Martin Pickering, and I really hope that you enjoyed this video. If you did, consider subscribing to the channel for more videos like this one. Subscribing is always free and just means that YouTube shows you my latest videos once uploaded and you won't miss out. So hit that subscribe button now. While at it, why not check out my super cool new lineup of t-shirt designs like this one, all available in my online merch store with worldwide shipping. With several designs and colours to choose between, I'm sure that you'll love at least one of them. Anyway, thanks for watching and I'll see you all in the next one.